Today we're going to watch what happened when the first stars ran out of fuel. And in fact the same thing happens in stars today. The details are slightly different, but the principle is the same. So let's watch a star during its main sequence, the main part of its life. A star depends upon the balance of forces. So this is a typical star, and inside there are two different kinds of forces. The inward force of gravity, which as we've seen was what formed the star in the first place, and it keeps the star together. It keeps the centre of the star hot, and this creates fusion. Fusion releases radiation. Radiation travels outwards and creates an outward pressure, and these two forces balance each other so the star is stable. It doesn't expand, it doesn't shrink, it just shines. In the first stars, this balance did not last very long. The stars soon began to run out of protons which they could fuse together at the centre. So the fusion slowed, the flow of radiation slowed, and the force of gravity took over. The star contracted. So as the star neared the end of its life, the core heated up. This made the outer part of the star expand, and the star was now large and red. So we call such a star a red giant. What's happening inside the star? New particles are being created because new fusions are happening, and this is possible because the star is now hotter. The inside of the star is now hotter than before. The outside, the visible part, is cooler. So it's a little bit of a paradox. But that's the situation. So at the centre of the star we have these new particles. One of them is called a carbon nucleus, made of 6 protons and 6 neutrons. Another one was the nitrogen nucleus, with 7 protons and 7 neutrons. And then there was the oxygen nucleus with 8 protons and 8 neutrons. These new particles were being created in the very centre of this red giant star. The outer parts of the star were hydrogen and helium atoms, and there was no fusion here at all. Inside that there was an outer core where protons were being fused into alpha particles, and then inside that again these new particles, the carbon, nitrogen and oxygen, were being created right in the centre of the star. These atoms, hydrogen, oxygen, nitrogen and carbon, will play a very important part in this story. They will form the basis of the molecules of life, which we'll talk about in later episodes. This phase of a star's life did not last very long, and so the star again contracted and heated up a little bit more, and so new fusions were possible at the very centre. These nuclei included neon, silicon and magnesium. The heaviest of these new nuclei was the iron nucleus, and this was the heaviest particle which was created inside a red giant star. And this is because to create nuclei heavier than iron requires that you add energy. So the star could not release more energy by fusing particles heavier than iron nuclei. Instead, that would absorb energy, which is totally different. So a red giant star has an iron core. These new particles which were created inside red giant stars, will form the central part, or the nucleus, of atoms later on in the story. And every different type of atom is called an element. So this table shows the relative abundance of the commonest elements in the universe today. So, out of every million atoms, 910,000 are made of hydrogen. And that's not surprising, because soon after the Big Bang, the only heavy particles in the universe were protons, and they form the nuclei, the central part, of hydrogen atoms. Helium is the next commonest, again not surprising because they were formed second and there were a lot of them. The heavy elements, the heavy particles formed inside red giant stars, which we've seen, oxygen, carbon and nitrogen, are the next commonest elements. Towards the end of the red giant star's life, we had that new inner core with neon, silicon, magnesium and iron atoms, and they are the next commonest elements. So, thank you for watching, and you can find more information about all these things on the History of the Universe website.